your slides, Chris. So take it away.
Yes, I've got rural internet, so I'm just not going to present my video. So everybody can see my presentation mode.
Sure can. Thanks.
Perfect. Again, I'm Chris Campbell with cbec Eco-Engineering. cbec has been working on the Lower Yolo restoration project since 2007 with various teaming partners. And today we're excited to provide an update on the implementation of this Tidal Marsh restoration project at the southern end of the Yolo bypass within the Cache Loop complex. This has been a long running project. We're in the landowner, Wetlands Water District, is delivering to the California Department of Water Resources a completed Tidal Marsh restoration project to partially satisfy their mitigation obligations under the management of the Hallmark Group and in direct collaboration with the department. The project was designed by cbec, permitted by ICF, and constructed by 4M Contracting. Today's presentation includes an overview of the regional conservation strategy, an overview of the project's background, design, as well as its implementation. As part of the regional conservation strategy and under the umbrella of the Eco Restore program, the program aims to advance the development of 30,000 acres of critical multi-benefit habitat restoration within the Central Valley, most of which is to satisfy mandates for habitat restoration pursuant to federal biological opinions to support the recovery of native fishes as part of continued operations of the State Water Project and the Central Valley Project. As shown by this graphic, there are several projects within the Eco Restore program within the legal delta shown in gray and the Yolo bypass shown in yellow. Completed projects, including Lower Yolo denoted by the red star, are shown by the table on the left, wherein those that are continue to be under development are shown by the table on the right. Within the Cache Loop complex, the limits of which are generally shown by the red dashed outline, Lower Yolo is one of a handful of projects designed to deliver critical habitat resources to the region. So why is developing habitat resources within the Cache Loop complex so important? The complex represents the critical intersection between the historical Sacramento River floodplain, which has been redefined by the Yolo bypass, and the North Delta. The complex provides important aquatic habitat and food resources for Delta smelt, as well as salmonids and numerous native fishes. At Lower Yolo, due to its location at the fluvial tidal interface, most of the site exists at natural intertidal and supertidal elevations and would inundate under a range of tidal and flood flow conditions. And the portion of Yolo Ranch targeted for restoration largely consists of unimproved grazing lands with relatively low productivity compared to the rest of the ranch. The importance of this site is further exemplified by the historical ecology investigation for the Delta prepared by the San Francisco Estuary Institute. The project site, shown by the red star, historically held a uniquely rich location at the intersection of the Puda Creek alluvial fan, the historic Yolo Basin floodway, and the North Delta tidal marshes. Before being diked and reclaimed for agricultural use in the early and mid 1900s, the site supported a combination of grasslands, seasonal wetlands, backwater lakes, and tidal marsh. The restoration project is effectively restoring these areas that were historically wetlands prior to the 20th century. As mentioned previously, the site has primarily been used for irrigated pasture to support large-scale cattle grazing operations over the last several decades. Wetlands Water District purchased the property in 2007 with the intent to develop a habitat restoration project. In total, and as shown by the black outline, the ranch is 3,127 acres, of which 2,149 acres were restored, as shown by the green dashed outline. The remaining 1,278 acres will remain in irrigated pasture and serve to self-mitigate for impacts to agricultural production, as well as provide for a conservation easement for Swainson's hawk foraging. Neighboring land uses include the naturally reclaimed lands to the south of Liberty Island and Little Holland Tract, the constructed Tidal Marsh at Yolo Flyway Farms to the northeast, which is the sister project to Lower Yolo and was constructed in 2018, and wetlands to the north that are managed for waterfowl on Mound Farms. More specifically, the goals of the project are to partially satisfy the federally imposed 8,000-acre tidal restoration obligations for continued operations of the two water projects, as well as serve as near-term action for eco-restore, with the objectives to, 1, support the recovery of Delta smelt by enhancing regional food web productivity, 2, providing rearing habitats for out-migrating salmonids, and 3, more generally, to provide ecosystem services to support a broad range of other aquatic and wetland dependent species. Sorry about that. For a quick snapshot of the project development timeline, the subject property was purchased in 2007, and almost immediately baseline studies and preliminary concepts and evaluations were prepared over the ensuing years. Preliminary concepts initially called for moving more than 3 million cubic yards of earth to provide for immediate habitat benefits. Then in 2013, and similar to other restoration projects in the region, an expert panel was convened that included a field tour followed by a workshop. Members of the panel included folks from the Delta Science Program, DWR, USGS, the Bureau, and UC Davis, among other folks, including some restoration practitioners. The charge of the expert panel is to provide design recommendations, define hypotheses and experiments to be tested to contribute to adaptive management and to identify metrics and monitoring protocols. A key design recommendation from the expert panel was to take a more passive restoration approach, thereby working with existing land elevations and reserving lands for sea level rise accommodation, given the project's location at the fluvial tidal interface. This ultimately resulted in a refined concept moving less than 300,000 cubic yards, or a tenth of what was originally proposed. As part of the expert panel consultation, a subsidy marsh concept was also put forth that included infrastructure as part of the restoration that could be adaptively managed to enhance tidal pumping, with the thought that it could enhance food web productivity and export. However, and following a lengthy pause of the project, coordination with the Department of Water Resources resulted in removal of the subsidy marsh component in favor of minimizing long-term operations, maintenance, and management of hard infrastructure associated with the original design. As the project resumed in 2017, final designs were prepared, and extensive coordination with state, federal, and local agencies was needed to acquire approvals for project implementation and demonstrate to the flood control agencies that balancing cut fill on site would not result in impacts to flood conveyance capacity within the Yolo bypass. Final designs were completed in 2019, and the project was ultimately constructed under a compressed schedule in summer 2020. The construction schedule, which was intended to start in May but was delayed until August, was compressed due to the presence of multiple Swainson's hawk nests affecting the project area, as well as black rail presence near the proposed spoils area. However, the contractor was very adaptable to the circumstances, and design modifications and field fits were made in real time to accommodate the impacted schedule, as well as enhance tidal floodplain connectivity. Recordation of the various conservation easements for habitat, Swainson's hawk, and agriculture is still ongoing a year later as part of final delivery of the project to the department. The project resulted in enhancement and restoration of more than 1,700 acres of tidal marsh, and enhancement of more than 400 acres of seasonal floodplain and transitional uplands, as well as riparian habitats. This is largely achieved by removing the grazing pressure, moving the least amount of earth, and opening the site back up to tidal action. As shown by the graphic to the right and the table to the left, the 2,149 acre restoration area largely included the enhancement and restoration of tidal marsh shown in blue and cyan, which included high intertidal and supratidal lands that provide resiliency to sea level rise. The supratidal zone represents the transition from tidal marsh to uplands, and given that the project site is within the Yolo bypass floodway, these areas are expected to become regularly inundating during spring tide conditions, seasonal floodplain activation via Fremont Weir overtopping in the planned future Big Notch project, as well as from backwater effects due to future sea level rise. Sea level rise is expected to be about a foot by 2050 based on guidance, and it is expected that the supratidal habitats will convert to intertidal habitats by 2050. Above the supratidal limits, transitional uplands shown in yellow provide for additional sea level rise accommodation, as well as contribute to the settlement agreement with Yolo County under their habitat mitigation ordinance. As such, much of the transitional uplands shown in yellow and including the remainder property that will remain in agriculture as shown in brown, provide for continued grazing to offset agricultural impacts, but only flash grazing is intended for the transitional uplands to manage for non-natives. The following two slides show the project area during construction. The lower inset graphic depicting the field of view with the blue arrow shows the property boundary in black, the project boundary in red, and the design grading extents in blue. Looking from the southwest corner of the restoration site, the project grading included excavation of new tidal channels with a primary connection to Liberty Cut, deepening of existing canals to minimize earthwork while still providing necessary tidal connectivity, breaching of numerous agricultural field berms in several locations to enhance floodplain connectivity, shallow skim grading over larger disturbance areas to expand the extent of tidal marsh, which was balanced in part by shallow transitional upland fills, with the remainder of the spoils used to construct a perimeter berm between the restoration property and the remainder property. The perimeter berm also serves to provide access to the restoration property along its entire perimeter, as well as a corridor to move cattle between the western and eastern portions of the remainder property. As shown here, and looking from the center of the restoration site to the northeast, the project grading included providing a direct connection and expansion to the Yolo Flyway Farms tidal restoration project, which, as said before, was constructed in summer 2018. This area of the restoration property is hydrologically isolated from the balance of the restoration property during tidal conditions, but it is connected during flood events. Due to the need to maintain a point of diversion on the tow drain, an irrigation canal was retained that services the remainder property as it also services offsite managed wetlands at Mound Farms. The following construction photos show the various construction activities that included fish rescue operations from existing irrigation canals that were intended to be deepened or reclaimed as tidal channels, extensive harvesting of tules from vast disturbance areas, which were temporarily stockpiled and irrigated on site prior to transplanting them into the lower lying intertidal areas. Here we have the excavation of new tidal channels as well as the deepening of existing canals, taking advantage of the existing irrigation network that was out there so as to minimize the amount of dirt that we were moving. Sorry about that. The excavation of interior breaches to connect the various areas within the restoration property, including the connection to Yolo Flyway Farms as shown in the lower right. And finally, the excavation of exterior breaches to connect the restoration area to the tow drain to enhance flood flow activation, along with removal of tide gate infrastructure to provide the primary tidal connection to the delta. The upper left photo shows a culvert along the tow drain being removed, but as part of a field fit, this excavation area was left open to enhance floodplain connectivity, so smaller flood flows coming down the Yolo bypass could more readily activate the restoration area, as well as future planned big notch project flows that would entrain more flow and juvenile salmon into the bypass. These fish would have an opportunity to more readily access the property from the tow drain. These photos show the constructed condition during varying tidal conditions. The upper left photo shows constructed tidal channels extending from Yolo Flyway Farms to the west through high intertidal and supertidal areas. The lower right photo shows constructed tidal channels through an intertidal area in the southeast of the site, where there was already fairly significant emergent marsh establishment due to prior flood irrigation practices. And so this is one of those fields that was not that great for grazing, but because of that, it did have a pretty significant existing emergent marsh on site. Following construction, long-term performance monitoring at some point here will be conducted by the Department of Fish and Wildlife with a focus on food web production and water quality, and conducted in a manner that will help to standardize the monitoring methods across the various restoration projects in the region. However, and as previously stated, project closeout with the department is still ongoing. In addition to recording the various conservation easements, the department is looking to leverage credit towards their newly acquired incidental take permit for operations of the state water project, which was not within the original purview of the restoration project. As part of that process, additional technical analyses were needed to be performed post-construction. And thinking, just to close it out here, thinking about some lessons learned, I offer the following. First, given the sort of long project hiatus, we should have re-engaged the agencies on key design assumptions, especially if the project is intended to be used to fulfill a new obligation. Two, consult with CalGEM very early in the design process to address costly gas well re-abandonment concerns sooner rather than later. Thankfully, we were able to negotiate with CalGEM and avoid what could have been very costly re-abandonment. For a project like ours with very shallow cut fills, and we're talking anywhere from half a foot to a foot, a pre-construction elevation survey using more traditional methods should have been conducted during the design process versus by the contractor at the start of construction. Our source elevation map for design was largely LiDAR based, and like most LiDAR products, vegetation introduces small errors that can obscure the true ground. As such, design modifications had to be made on the fly during construction to balance cut fill on site. And lastly, we should have re-engaged with vector control when this project resumed in 2017. While the project site prior to construction was historically an issue area for mosquitoes due to flood irrigation practices in the vector district spending hundreds of thousands of dollars on vector control, we were not anticipating it to continue to be an issue across the restoration site, and it is in a couple areas. Some of the high intertidal areas with very shallow existing land slopes and micro depressions that were not graded are relatively slow to drain. I'm not convinced that an additional design review by vector control would have identified those issues. That said, vector control is actively working with the project team, and they have access to new low pressure ground equipment with a rotary ditcher, and they are considering adaptive management opportunities to create shallow swales to effectively drain these vector hotspots. So with that, I'd like to open it up to questions.
Great, thank you, Chris.
Our first reminder to drop your questions in the chat, or not the chat, sorry, the Q&A box. Let's see. So our first question here is from Annabelle Law. She asks, does cattle grazing and agriculture on adjacent lands directly or indirectly affect the restoration of wetlands?
It does not. So the lands that are remaining in grazing, they are hydrologically, at least superficially isolated from the restored footprint during, normal tidal conditions. It's not until you have, system-wide flooding in the bypass everything is basically hydraulically connected. But so during, normal tidal conditions, there's no runoff from the agricultural area that feeds into the restoration footprint. Most of the agricultural area is sort of self-recycling. In addition to sort of tidally charging their canals, they also drain back into those canals and relift that water. So yeah, there's no sort of direct impact from the agricultural grazing that influences the productivity of the site.
Great, thank you. We also have one question from Joanna Tong. She asked, or she says, first, it's really great to hear about all your collaborators on the project. Then asks if you could talk more about how you engaged various stakeholders in the decision-making process.
Yeah, so in terms of sort of stakeholder engagement, early on, there was a number of, activities or workshops as part of the environmental review documentation rollout. It was not until later in the design process, significantly way into the design process back in 2013, that we engaged with an expert panel. This was following the expert panel process that had played itself out with the Prospect Island tidal restoration project. Granted, the expert panel interactions with Lower Yolo, it was a much smaller scale effort. But with that project, or with that process, there was definitely a lot of collaboration with those various agencies through that workshop. Unfortunately, then, the project basically sat on the shelf for several years, and then finally Wetlands was able to re-engage. With that, we continue to consult with Fish and Wildlife Service and CDFW and the department as we, repicked up the design and created final designs for the project. Like I mentioned, it would have been probably would have been useful to re-engage with vector control on their review of the design. So that's more or less the extent of our sort of engagement there at the beginning of the project, as well as at the near the end of the project.
Great. That is all the time we have for questions. There's a couple more in the Q&A box. Chris, if you have a chance to answer those, you can reply there via, typing and that sort of thing.
Okay, great.
Thanks again. So next up we have Gwen Santos. Gwen is a senior wetland ecologist with RES. Oh, sorry, I moved my thing. Okay, yes. Gwen is a senior wetland ecologist with RES and the lead ecologist for the Klamath restoration team. Her background is in wetland and estuarine ecology, working in riparian, tidal marsh, vernal pools, and subtidal habitats. Gwen is co-presenting today with David Kaufman, who is a senior fluvial geomorphologist with RES and is the Klamath restoration team program manager. David has extensive experience restoring degraded environments at scale. Thank you, Gwen. It looks like I can't see your slides quite yet.
Oh, let me start sharing. Thank you for that intro. Here we go. All right.
There we are.
Okay, perfect. Well, thanks everybody for joining us. Dave and I are going to talk about restoration elements of the Lower Klamath project today. There we go. As Keely mentioned, Dave Kaufman is the Klamath Restoration Program Manager for RES, and